Hi, I'm Mr. V. This is Illustrative Mathematics, Unit 5, Solid Geometry, and we're on Lesson 8, speaking of scaling. And to do this, I'm going to look at the objectives today. By the end of the lesson, you should be able to say, I can calculate scale factors for lengths, surface areas, and volumes if I'm given any one of the three factors. And we start off with the bell work, which is this question. This cone in the orange has been dilated to get to this larger one. And what is the scale factor of the dilation? I'm going to show you how I would do this on a piece of paper over here, on my whiteboard. So we know that if we have the scale factor, this is going to be my K value is 0. This is where the K value is equal to 1. And this is going to be something greater than 1. So the K value is going to be greater than 1. And I want to know what it is. If K was between 0 and 1, I would be getting smaller. We also know that my length of the second one is going to be is proportional to the scale factor times the length of the first one. The area of the second one is proportional to the K factor squared times the area of the first one. And the volume of the second one is proportional to the K factor cubed of the volume of the second one. Of the volume of the first one. Now here we have an area, and it's colored in as an area. So I'm going to use this middle formula. My area 2 is equal to K squared times my area 1. This is my formula. When I substitute the values, it's going to be 729 pi. I could be getting smaller, but I'm not. I'm getting larger. Is equal to K squared times 36 pi. And when I solve this, I'll divide both sides by 36 pi. So if I do this on my screen here, 729 divided by 36. And if I put pi in there, pi is divided by pi, I get 20.25. So K squared is equal to 20.25. And now to find K, I'm going to do the inverse operation. I'll do the same thing to the left side as I do to the right. I'll take the square root of both sides. So I'm going to take the square root of 20.25. So I take this, I'll take the square root of that, 20.25. I get 4.5. So my K value, my scale factor is 4.5. And I did this using my knowledge of volumes, areas, lengths, and how the scale factor relates to those. So going on with our lesson, today we did an info gap. The question is, first of all, you have a problem card and you have a data card. And we did the first one as a class where the students had the problem. They had to come up with the right questions. And among some of the questions that they asked were, do you know the length of the original? Do you know the width of the original? Do you know the height of the original? And then they said, do you know the length, width, and height of the dilated one? And I can only answer them with what was given on the data card. At some point, we came to the point where we both looked at both cards. We both looked at both cards. And I'll show you this. I'm going to copy this to my whiteboard so we can talk about it. Okay. When they did this with me, I marked it. Let me see if I can find it here on this drawing. This is where I started with. They asked me, do you know the height of the original prism? No. Do you know the width of the original prism? No. Do you know the volume of the original? Yeah, I know the volume. Do you know the surface area? Yeah. Do you know the length? Yeah, I know the length of the original. It's this much. Do you know the volume of the second one, of the dilated version? Yeah. And with these two volumes, I could find the K. Someone asked me, do you know the scale factor? No, I don't know that. I was not given that information. Then they said, well, do you know the length of the second one? No. Do you know the width of the second one? No. Finally, somebody said, do you know the height of the second one? Yeah, I know the height of the second one. It's given. Well, how do you know if the width is if you don't know what the height is? Well, we know the volume. Someone asked for the area. I don't need to know the second area if I've got the two volumes. I need to know either one or the other in order to find the scale factor. And so what I did was I took this picture here, and I said, because we're supposed to draw this diagram and mark it, I said, first of all, the volume 2 is equal to the k cubed times the volume 1. I know the volume in the end. I know the volume that I started with. So my k factor is 2. From this, I could say, well, if my L1 is 5, no, if my height is 4, then I could find my original height must be 2 because it's the scale factor times the height. And from this, I said, okay, my height original is here. I also was given my length original was 5 because that was given. And the volume is 30. So since the volume is length times width times height, 30 is equal to 5 times W times 2. My W1 is 3. And then I could label the diagram. And this was the procedure that we sort of went through to do this infogram. On the second one, we had a cylinder, and we had to do the same kind of thing. The idea behind both of these is that if you have the length of one times some scale factor, you get the length of the other. If I have the area of one, it'll be times the scale factor squared to get the area of the other. And if I have the volume of one, it'll be the scale factor cubed to get the volume of the other. Now, if I know any two of these, I can find the scale factor. So from the scale factor, you give me any one of these others, and I can find any of them missing. That's the big idea of today's lesson. We did this with this fellow. Let me see if I can copy this over and talk you through this. There is the dialogue that goes with this, and we follow the dialogue pretty strictly in order to have everybody have a say in what's going on. So the person with the data card starts by saying, what specific information do you need? Do you know the volume of the dilated cylinder? Why do you need that? Well, that's what I'm looking for. No, I do not have that information. What information do you need? Do you have the area of the dilated cylinder? Why do you need that? Well, I'm looking for the volume, and if I knew the area of the dilated and the original, then I could find the scale factor, and maybe I could figure out what it's going to be. I have that information. That information is 1280 pi. Okay. What specific information do you need? Do you have the volume of the surface area of the original? Of the original. Why do you need the information? Well, I've got the dilated version's surface area. If I knew the other one, I could figure out the scale factor. I have that information, and it is 80 pi. So from this, the person could say the area 2 is equal to k squared times area 1. And so you have 1280 pi is equal to k squared times 80 pi. And from this, we'll divide both sides by 80 pi. K squared is equal to 16, and k is equal to 4. Oh, I got the scale factor. That's not going to help. That's not what I needed. I know the volume of the dilated cylinder. Okay, what specific information do you need? Do you have the volume of the original cylinder? Why do you need information? I'm trying to find the volume of the dilated cylinder, so I've got the scale factor. I just need to know what the original was. I have that information, and it is 75 pi meters cubed. And I have enough information to solve. So together, you both try to solve it individually, and you come up with an answer. I'm going to say my volume 2 is equal to k cubed times my volume 1. So I have volume 2 is equal to 4 cubed times 75 pi, and that's equal to some number. And I'll compare it with my partners, and if we disagree, we'll talk it over and decide who's correct. And that's pretty much all that we got through today. We did do this. There's an activity called the jumbo cans, and which juices do you like? And we have a couple of people like banana juice. Somebody likes banana, just plain water. Okay. There wasn't any banana juice up here. Okay, fine. So there's this activity about beverage containers. There's also an activity about the tower. Now, I love this tower. What is it called? The Burj Khalifa. It's the tallest building in the world. Look at how tall that is. I mean, that's just, and for years it was the Eiffel Tower, which is about half as tall as this. That's about 35 years, 40 years. Then for 3,000 years, it was the pyramids, which were even shorter still. But this is one tall building. And for the lesson synthesis, main idea of this lesson is we know the scale factor by which volumes and surface areas or lengths change when a solid is dilated. It's possible to find this factor of the remaining values and how they change. And you can read through this and along with my answers, and then do this cool down, which is about the pet supply company. I think you get like 6.5, around 6.5, somewhere in there, I'm estimating. And good luck with this. Good luck and success.